Hello, hi. Myself, Dr. Vinod, working as Associate Professor in the Department of Electrical and Electronics Engineering, Marri Laxman Institute of Technology and Management. Today, let us start the session. Subject is Basic Electrical Engineering, in which the major topic we are covering today is Superposition Theorem. The Superposition Theorem. The superposition theorem, as we know that this is an important network theorem used in electric circuit analysis. So whenever we talk about any theorem or whenever we talk about any kind of electrical theorem or mathematics theorem, generally what it signifies. So whenever we go with a theorem, it shows like easy process to solve the problem. So the superposition theorem is helpful to solve the complex problems. So generally this is useful for analyzing the linear circuits that contain more than one independent source. So here the context is this is applicable more than one independent source. This theorem helps simply, as I told, simplifying the complex circuit by allowing us to consider the effect of one source at a time. Suppose we have multiple sources, so we have to calculate the effect of source one at a time. And the statement says like this. The statement of superposition theorem states, in any linear bilateral network containing at least two energy sources, the current flowing through a particular branch is algebraic sum of the currents flowing through that branch. When each source is considered separately and remaining sources are replaced by their respective internal resistance. So what it indicates, let us go line by line. In a linear bilateral network, whenever in a linear bilateral network and a complex network, we say like, so containing at least two energy sources. As already we have discussed that there must be more than one independent source. So the statement says like two more, that is at least two energy sources in which the current flowing through a particular branch is algebraic sum of current flowing each source is considered. Suppose I wanted to find out the current in a particular branch, then I have to go with two energy sources independently, where one energy source, if at all I am going with, the other energy source is replaced by internal resistance. So let us see this superposition theorem in detail. So while considering the effect of one source, all other sources independent must be replaced by internal resistance. So this simplifies the circuit and makes analysis easier. So the point to be noted is, if two independent sources are considered, so one independent source is acting alone, other independent source is replaced by internal resistance, and the superposition theorem is worked when it is more than one independent source. So how to deactivate sources in superposition theorem. Here you are. While applying the superposition theorem, the sources are deactivated as follows. So that ideal voltage source replaced by short circuit. This is the most important thing while solving the problem for superposition theorem. And similarly, the ideal current source is replaced by with the open circuit. And the dependent sources are not deactivated, remain active during the analysis. So whenever we are going with deactivation, so then the ideal voltage source is replaced by the short circuit. Ideal current source is replaced by an open circuit. Voltage source is replaced by short circuit. Current source replaced by open circuit. So dependent sources are not deactivated, then they remain active throughout the analysis. So let us see the physical meaning of the superposition theorem. The superposition theorem is generally based on the principle of linearity. In linear circuit, we see like the response produced by multiple sources acting together, that is equal to sum of the responses produced by acting independently. So the meaning says as like, I am going with one independent source acting alone. So I have more than one independent sources in a circuit. So then for suppose I consider one acting alone, the other one will be replaced by internal resistance. I calculate the value. Second case, I go with the second one is acting, then the other one is replaced by internal resistance. So I sum up those two energies, I sum up those two values such that I am going to get the current to that particular branch or particular resistance, whatever I need to calculate. Then that's why the sum of the responses produced by each source is acting independently. So once again repeating here, the physical meaning says like the response produced by multiple sources together, two sources acting alone is equal to one acting alone plus two acting alone. So the sum of the responses produced by each source is acting independently. This principle does not apply for power calculations directly. So this is a what is this? I can say like for competitive exams, they may ask like the superposition theorem where it is not applicable. So there you can write straight away the power calculation straight away. We cannot do for superposition theorem because as we know like power is a non-linear quantity. So therefore superposition theorem is used to find out the voltage or current across that particular branch or particular resistor, but not power. Next, let us see the steps that are applying for superposition theorem. Let us see the systematic steps while solving the numerical problems. First, we have to identify the all independent sources that are existing in the circuit. Second one, choose one source and deactivate all the other. Analyze the circuit to find current or voltage due to that source. Repeat the process for each independent source. Right now, add all the individual responses algebraically. So once again, I am repeating the steps that need to be followed. Is first one is we have to identify the all independent sources in the circuit. Second one, the choose one source and deactivate all others. And after that, other sources. Whenever you have two sources, one will be acting, another will be deactivated. So third one is analyze the circuit to find out current or voltage due to that source, and we have to repeat this process for each independent source. Suppose I have two independent sources, then my process will be for two times. If at all my circuit, what I'm trying to solve it is for three sources, three independent sources, then I have to repeat it for three times. And finally all the individual responses algebraically added. Okay, let us see the superposition theorem explanation. Here we find two voltage sources. So the context is here at this particular branch. I need to find out the current. That's why it indicated like I. So this is the explanation itself. While solving the problem, I will be throwing more light on this. Okay. So first, I consider the circuit as shown in the figure. So we need to estimate the current through using the superposition theorem. So first, we consider the voltage source. V1 is acting alone. Then what happens? Then we have to remove the other voltage source by replacing the internal resistance. As the internal resistance of ideal voltage source is 0, then it is replaced by a short circuit. So this is the most important point while solving the problems during an exam or particularly in competitive exam. So students may get confused at this point. What is that? Whenever we try to straight away we say like voltage source, if ideal voltage source is 0, then it is replaced by short circuit. So if it is not, then already I told in the previous slide, it has to be replaced by internal resistance. The current through RL is I dash. Why we are considering this current I into I dash and I double dash? Because one source is acting at a time, I consider the first source, so I dash. Whenever I am considering the second source, I am considering that value as I double dash, because I need to add up. So if I take I again, that will be a confusion. So I am going for the first source, I am going with I dash. Second source, I am going with I double dash. Similarly, there V1 is acting, and we have this is a V1 is acting, the first case 1. Next, case 2 is V2 is acting. So the diagram is here. V2 is acting. So as this is the ideal voltage source, so you are making this as short circuit. Similarly, as V1 is acting, V2 is ideal voltage source, then we are making this as short circuit. So here I dash and I dash can calculate by using Kirchhoff voltage law. Already we have discussed in the previous lectures. Therefore, the current flowing through RL when both voltage sources are acting, that is I equal to I dash plus I double dash. So finally the I'm summing up with 1 or 2 points whatever we have discussed so far. That is, first point is superposition theorem must have more than one independent source. So if two independent sources, then one will be acting, other will be deactivated. Case 1. Case 2 is second one is activated, first one is deactivated. After that we have to add the both energies such that we are going to get the answer, that is the final one. So first one I go with I dash, second one I go with I double dash. So the total current, if I wanted to get that particular branch, then I have to add I equal to I dash plus I double dash. So let us see the problem. The superposition theorem numerical. So this is a circuit. If you see here, my question is I need to find out the current flowing through the 20 ohm resistance. So I have indicated this with a red mark, red ink. So totally how many sources are here? Here we have two sources. One is 4 volt, another one is 8 volt. So more than one independent sources. Right now I am eligible to apply the superposition theorem. So first I consider one source, that is I am considering the 4 volts. So as we have 4 volt and 8 volt, first I am going considering only 4 volt. Then what about other 8 volts? So already we have discussed, if one is acting, the other will be deactivated. So that deactivated will be short circuited. So that's why this is short circuited. So 4 volt, we are considering the same circuit. So this is I1, this is I2, this is loop 1, this is loop 2. So loop 1 current is I1, loop 2 current is I2. So mesh analysis, I am going for mesh analysis. So in which first let us consider the loop 1. So this loop 1, let us catch the second terminal, and plus minus plus, I am giving here plus minus plus minus plus minus plus minus. So this case this is plus minus. So this is for loop 1, this is for loop 2. So in this case if you see 4 volt is plus minus 10 into I1, 10 into, catch the second terminal. So minus 10 I1 minus 5 I1 minus I2 is equal to 0. Finally I am going to get minus 15 I1 plus 5 I2 is equal to minus 4. Mesh 2. In the mesh 2, if you see, I am catching the second terminal. If you see here, that is minus 20 I2 minus 10 I2 minus of I2 minus I1 is equal to 0. If I keep on solving, finally I am going to get 5 I1 minus 35 I2 is equal to 0. This is I1 is equal to 0.28, I2 is equal to 0.04. So finally I20 dash is equal to 0.04 amperes. So here, while calculating the I20, I-20 ohm, so I have to follow this process. Next, first activated, second is deactivated. Next, I am going for second source activated, first source is deactivated. So next I am considering the 8 volts, that is source is active. When 8 volts is active, then what about 4 volt? 4 volt is obviously it is a short circuited one. So this is short circuit, this is case 2. So similarly I1, I2 plus minus plus minus plus minus plus minus, plus, minus. This is for loop 1. This is for loop 2. So mesh 1 equation when second source is acting, that is minus 10 I1 minus 5 I1 minus I2. So that is minus 15 I1 plus 5 I2 is equal to 0. So next mesh 2 is mesh 2 or loop 2, that is plus minus plus minus plus minus. So here this is, so 8 is positive, minus, that is second, cancel second terminal, minus 20 I2 minus 10 I2 minus 5 I2 minus I1. So if you see this, 5 I1 minus 35 I2 is equal to minus 8. So I1 is equal to 0.08, I2 is equal to 0.24. So I20 ohm double dash is equal to 0.24 amperes. This is for the second source acting while the first source is deactivated. So finally, the I20 ohm is equal to source 1 plus source 2 current. So finally, I am going to get I20 ohm is equal to 0.28 amperes. Thank you.